Our last section in chapter 1 is about dimensional analysis. And dimensional analysis, what it is, it's simply a method for solving problems by analyzing the units. So we're going to be doing some analysis of the units and using that to determine what the answer is. Sometimes with dimensional analysis, you can solve problems without necessarily even understanding the problems. Now, I don't recommend that. Obviously, it's better to understand the problems, but it can help you solve problems that maybe you weren't going to be able to answer otherwise. So here's an example of a problem we can solve. How many centimeters are in 26.22 miles? Now, offhand, you probably don't know how many centimeters are in a mile because who would know that, right? That's not a useful bit of information. But using the back of your periodic table, there's some conversions there that are quite useful. We know that 1 mile is equal to 5,280 feet. And so two possible conversion factors that we could use are the 5,280 feet over 1 mile or 1 mile over 5,280 feet. All right, so that tells us how many feet are in a mile. Well, we know that there are 12 inches in a foot, so our two possible conversions there are 1 foot over 12 inches or 12 inches over 1 foot. And then finally, we know that 1 inch is equal to 2.54 centimeters, and that is an exact value. And there's kind of an interesting story behind that, but I will save that for some other time. If you ever happen to drop by my office, I'll be glad to go over that. But 2.54 centimeters over 1 inch, or 1 inch over 2.54 centimeters. Okay, so now we've got that. So let's apply these, and we're just going to multiply by combinations of these conversion factors to get us to the final answer. And in doing that, we're going to cancel out units. So let's start by writing the number that we had to begin with, which is the 26.22 miles. And that, by the way, that's the length of a marathon. And we want to multiply to get to feet. And when we get to feet, we're going to multiply by this first conversion, 5,280 feet over 1 mile. And when we do that, you will see that we've got miles up in the numerator and a mile down in the denominator. And so the miles cancels out. And so now we have our answer in feet. Well, next we want to convert to inches. We have 1 over 12 and 12 over 1. We're going to use the 12 over 1. So we're going to multiply by 12 inches over 1 foot. And so the feet cancel out, and that gives us our answer in inches. And similarly, we're going to multiply by 2.54 centimeters over 1 inch, and we'll cancel out inch, and that will give us our answer in centimeters. And so our answer comes out to 4.220 times 10 to the 6 centimeters, or 4.220 million centimeters. So if you happen to run a marathon, you can impress people by telling them how many centimeters you ran. I don't know that it's really that impressive to say in centimeters. It's impressive if you can run a marathon. All right. Next, so this one's a simple problem. The reason I call it simple is that we have 1 unit and we're converting that 1 unit into some other unit. Even if we're taking several steps, this counts as a simple problem. So next, what we want to do is we want to do one that has 2 different dimensions, like you might have with a rate or a speed or something like that. So here we've got convert 126 meters per second into miles per hour. Well, we have 2 different conversions that we need to do. We need to convert the meters into miles, and we need to convert the seconds into hours. And we will do those separately. Now, we'll do them on the same line, but we're going to do them in steps. So here are some useful conversions. 1 kilometer is 1,000 meters. That's a definition value. 1 mile is 1.6093 kilometers. All right, 1 hour is 60 minutes and 1 minute is 60 seconds. Those last two, I don't have those on the back of the periodic table. You will have to memorize those yourself. So first, we've got the 126 meters per second. When I'm doing a problem like this, I always prefer, when I've got 2 units to convert, I always prefer to convert the unit that's up on top first. You don't have to do it that way, but since we're converting meters into miles and we have meters per second, I always do the one that's up on top first, but that's just so I'm consistent and I'm always doing it the same way. So we'll need to convert the meters into miles. We can do that in 2 steps here. We've got 1,000 meters is equal to 1 kilometer. So that gets us to kilometers per second. And then next we can multiply by this 1 mile over 1.6093 kilometers. All right, there you'll see we canceled out our meters. And so 1 mile over 1.6093 kilometers, and you'll see the kilometers cancel out. Next, we want, so now we have miles per second. So next we want to convert the seconds into hours. And so 60 seconds is 1 minute. Always pay attention to where your unit is. This unit is in the denominator. So I'm going to put the 60 seconds up here in the numerator, and you'll see that our seconds cancel out. And then we'll do the same thing with hours and minutes. So we'll put the minutes up here in the numerator, 60 minutes over 1 hour, and you'll see our minutes cancel out. And when we do that, we end up with miles per hour. Those are the only units that are left. So that is our answer. And the answer comes out to 282 miles per hour. So hopefully this is not a word problem where a car was going that fast, unless it's on a racetrack, a very, very fast racetrack. All right, so 282 miles per hour. That's pretty darn fast. All right, so that is a 2-dimension. So now we're going to do a problem where we have a higher order dimension. And this is like where we have units squared or units cubed. So here it says, convert 203 cubic or square centimeters to inches squared. So we want to go from centimeters squared to inches squared. And this is not too bad. We only need the one conversion, which is that 1 inch is equal to 2.54 centimeters. We just need to use that conversion factor twice, or we can just square that conversion factor. And so here is how I would write this. So I've got 203 centimeters squared. And if we multiply by 1 over 2.54, but we square the conversion factor, that will take care of squaring the units. When you have your conversion factor here inside the parentheses, you're going to square all of the numbers and all of the units. So we'll have 1 squared, inch squared, 2.54 squared. It's important to remember that. And centimeters squared. And then the centimeters will cancel out, and we will end up with our answer, which comes out to 31.5 inches squared. All right, so now we're going to go look at number 47 on the in-class assignment. So let's come over here to number 47, in-class assignment. And I got my calculator. All right, so the very first problem is a very simple problem. 5.00 days, and we want to convert that to seconds. There's a pretty good chance that you could punch these numbers into the calculator and get the answer to this without writing a single thing down. I'm going to discourage you from doing that. And the reason I'm going to discourage you from doing that is that I don't want you to skip the step of writing it down. It's worth it to write it down. So we'll put 5.00 days, and we'll need a conversion from days to hours. I don't know the exact conversion from days to seconds, so we'll go from hours, days to hours to minutes to seconds. And so 1 day is equal to 24 hours. So 24 hours is 1 day. And that we know in every hour it is 60 minutes. So 60 minutes is equal to 1 hour. And then 60 seconds. So 60 seconds is equal to 1 minute. My minute got a little messed up there, but you can forgive me for that. And so now our days will cancel out. Hours will cancel out. Minutes will cancel out. And our answer is going to be in seconds. So we'll do 5 times 24 times 60 times 60. When they're all just going across the top, they're all in the numerator. Our numbers on the denominator are all 1. You can just multiply them out, and it's no big deal. And you'll see we get 432,000, which I'm just going to call, I'm going to call that 432,000 seconds. You could, of course, write that as 4.32 times 10 to the 5th seconds, and that would be the correct answer as well. All right, next we've got miles to meters. So 0.0550 miles to meters. 0.0550 miles, and we want to convert to meters. And so I've got the back of the periodic table here. Well, all right, and our length. We can use the exact number, or you can round it. It doesn't particularly matter here. I'll go ahead and use that exact number since we have it, but 1,609.344 meters is equal to 1 mile. So 1,609.344 meters. We don't need anywhere near that many significant figures, but that's okay. 1 mile. And then that's it. I don't need an equal sign there. I mean, I don't need a multiplication. I need an equal sign. All right, so 0.0550 times 1,609.344. And that gives us 88.5 meters. So 88.5 meters. Now, if you hadn't written down this whole conversion factor, let's say you had written down just 1,609. You didn't write down the 0.344. Chances are you're going to come out pretty close to the same answer, and you'll probably have the same answer with that many sig figs. So I'm going to do 0.0550 times 1,609. And you'll see it says 88.495, but when that rounds, that comes out to 88.5. Generally, the best approach is to have at least as many sig figs in your conversion factor as you have in your initial measurement. You can always put more in your conversion factor, but if you put less, then that means you're going to have fewer sig figs in your answer. For part C, you'll see that we've got two different dimensions here. We need to convert gallons into liters and minutes into seconds. Well, that's pretty easy. So 22.50 gallons per minute. All right, and I prefer to do the top unit first. So we'll come over here for volume. 1 gallon is 3.7854 liters. That's not exact, but that's enough sig figs. So 1 gallon is 3.7854 liters. And then and that gets us to liters per minute. And you'll see here, I forgot to cancel those out. Gallons cancel out. And then you'll also here want to cancel out the minutes. We want to convert those minutes into seconds. And so we've got 1 minute is equal to 60 seconds. And then you'll see that the minutes cancel out. All right. On this one, now that we have a number that is not 0 or not 1 in the denominator, you'll want to be careful. Here, it's not a big deal, but you'll want to be careful when you're doing these calculations. And I'll show you an approach to doing this. You do 22.50 times 3.7854. All right. And then and if you just hit enter, and then in most calculators, if you just hit the next operation, so multiply by 1 over 60, you can divide by 60, and that will give you your answer. So 1.4195, we've got 4 significant figures here. This one has 5, And this one, because it's exact, it's a definition value, it has an infinite number of significant figures. So our answer is going to have 4 significant figures. All right, so I'm going to go ahead and write down the number in the calculator, 1.419525. That's way too many. We have 4, so I'm going to put 1.4. We're going to round that 9 up, and so that's going to be 1.420 liters per second. All right. Next, we've got cubic feet to cubic centimeters. And we know that 1 foot is equal to 12 inches, and that 1 inch is 2.54 centimeters. And with those two conversions, we can do this problem. So 0.0250 feet cubed. All right. So let's convert to cubic inches next. So we'll have 12 inches over 1 foot. And since this is cubed, we're going to want to cube that conversion factor. So we'll want to cube that conversion factor. Scoot that up a little bit. And then we'll do the 2.54 centimeters over 1 inch. And we'll also want to cube that conversion factor. And you'll see cubic feet cancel out and our cubic inches will cancel out. We do need to remember to cube those numbers that are inside those parentheses. So we'll do 0.0250 times 12 cubed times 2.54 cubed. All right. And that gives us 707.92. We come back over here and look, and we've got 3 sig figs. So we're going to go ahead and write that as 3 sig figs as 708 centimeters cubed. And that is our answer for that one. All right. Our last problem, I really like this last problem. It's the last problem in chapter 1. And you'll see one on the homework that is similar to this. It just has different numbers for the one on the homework, but it's good to practice this. So the density of air at ordinary atmospheric pressure and 25 degrees Celsius is 1.19 grams per liter, approximately that. What is the mass in kilograms of the air in a room that measures 12.5 by 15.5 by 8.0 feet? All right, the first thing to do on this is figure out what it is you're looking for. It's a word problem, and we're looking for mass. And it's a density problem, and we're looking for mass. We know that density is equal to the mass divided by the volume. Well, when we solve that for mass, mass is equal to the density times the volume. So mass is the density times the volume. All right, now that we've done that, density times volume, we just need to figure out, we've got a density at 1.19 grams per liter. We need to figure out what that volume is. So the volume of our room is equal to 12.5 feet times 15.5 feet times 8.0 feet. And so when we multiply that out, so 12.5 times 15.5 times 8.0, we get 1,550. So 1,550 cubic feet. Now, normally, if this were the end of the problem, if it said, oh, what's the volume of this room in cubic feet, you would go ahead and round this, and you'd call that, well, there's only 2 sig figs here. You'd round that and call it 1,600 feet. But since we're doing more of this calculation, we can leave that 1550 and then round it when we're done. We can round the final answer when we're done. We need to convert those cubic feet into liters. So cubic feet into liters. And there's a couple of different approaches that you can take for this, but we know that from our previous thing, we know that 1 foot is equal to 12 inches, that 1 inch is equal to 2.54 centimeters. Those are both conversion factors that we had. Well, that one's just one that's in our brain, and this one is one that is on our periodic table. And then we also know that 1 cubic centimeter is equal to 1 milliliter, and then we know that 1 liter is equal to 1,000 milliliters. And so using that, we can directly convert into liters. So we just need to use this correctly. So we'll do 1,550 cubic feet. All right, we'll go to cubic inches first. So 12 inches over 1 foot. But remember to cube that conversion factor. Next, from inches to cubic centimeters, we'll do 2.54 centimeters is equal to 1 inch. And we'll cube that conversion factor. And then 1 milliliter is 1 cubic centimeter. And then 1 liter is 1,000 milliliters. And that's going to give us our answer in liters. So we'll do times 12 cubed times 2.54 cubed, and then we'll divide by 1,000. And so here we've got 43,891 liters. Now that's more sig figs than we really need. So that's more sig figs than we really need, but we'll round, like I said, we will round at the end. So now that we've got this in liters, we can put that into our formula that we've rearranged and solve for mass here. So mass is equal to the density times the volume. Our density, as given in the problem, was 1.19 grams per liter. And then we're going to multiply that by 43,891 liters. Okay, and the liters cancel out there, and that's going to give us our answer in grams. So I'm just going to multiply this by 1.19. All right, and now we've got 52,230 grams. Now, that's not quite our answer because it does want us to give us the answer in kilograms. That's easy enough. So 52,230 grams. And there are 1,000 grams in 1 kilogram. And that's easy enough. We'll just divide by 1,000. And we'll get 52.23. So 52.23 kilograms. However, we're not quite done in terms of significant figures. And the reason is we've got too many significant figures in our answer. We come up here and we'll see that our initial measurements, we had 3 sig figs, 3 sig figs, and 2 sig figs, which means this volume really only had 2 sig figs. Well, if that only had 2 sig figs, this one's infinite, 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 infinite. That means this really only has 2 sig figs. So if we were rounding at this point, we would have called that 44,000 liters. All right, well, that has 2 sig figs. This one has 3. So our answer should have 2. And if that has 2, this answer should have 2. Our final answer here should be 52 kilograms. All right, and that is the end of chapter 1.